Nothing really kind of crazy going on with that. So from the center to another endpoint on the sphere, that represents our radius, and then passing through the center to the endpoints on that sphere, that is the diameter. Okay. Difference between the circle and the sphere is there is only one formula. The circle we could do for circumference 2 pi r, or what, pi d. Now that's for the circumference around it. We're not talking about circumference or anything. We're talking just about volume. We're not doing surface area or anything like that. But we are just doing the volume, so that's the space it occupies. So for the volume, as you got your formula sheets, just got to know what the radius is. And as I mentioned to you guys the other day, the biggest thing it can tell you is, are you using the right formula? And the thing that happens with most people is it's that formula with the 4/3 pi r cubed that gets mixed up with the cone, 1/3 pi r squared. It's that the threes and that squared just get jumbled up in your head. Please read that formula sheet carefully, okay? All right, we've been doing our revolutions, so let's go ahead and do another revolution here. Does it essentially give you what? A full sphere or a half a sphere? As we revolve it about the y-axis, I would again encourage you to draw that over that to give you that either a full circle or half a circle. But again, remembering it actually creates you a full sphere or a half a sphere. So when you revolve it about the y-axis, what's it going to do? Create you a full circle or half a circle on this one? Yes. About the y-axis comes this way. It's creating yourself a full circle, which really is creating you a full sphere. So we will say it is just a sphere. Sphere is again, full sphere. Okay. Now, from there, just like we were doing, as I was grading your guys' quizzes yesterday, some of you do a nice job on that first quiz of labeling your formulas, not even just labeling your formulas, but putting some formulas down there. Some of you guys did not do a good job of that, and I could not give you any partial credit. So some of you did lost some extra points, not even extra points, you just lost full points because you had no work, you missed it. I couldn't give you any credit off that. So I'll talk about that here in a few minutes when I pass those back. All right, it's a sphere. What do we have for a radius? Radius is what? Look closely, radius is what? 4. And then let's go to our calculator and let's just punch it in. Okay, directions say round it. Nope, it says volume to the nearest what? Nearest whole number. Now, as we always do though, I always like to just punch that in without pi at the moment. So let's go ahead and get it in terms of pi, and then we'll round it to the nearest whole number. So let's do like we've always been doing. 4 to the third is whatever. 4 to the third, one more time. 4 to the third is whatever, and then times 4/3, making sure you can correctly type that in. 4/3 times 4 to the third times 4/3. Again, your calculator is going to give you just not a nice decimal most of the time. Holy crap. And we get 256 pi over 3. Now, if the directions say leave it in terms of pi, again, that is what we want to see. As I'll pass back the quiz in just a few minutes, I don't remember what the question was, but it was like the second question. Some of you gave me, did not give me that. It says in terms of pi, you gave me the rounded decimal. That's not in terms of pi. Now, directions do say round to nearest whole number, so let's go back to our calculator and let's complete that by putting pi actually in there and dividing that by 3. Nearest whole number is going to be what? 268. We don't have units, so we just say our generic units cubed. Okay. What some of you did on your answers was you gave me something like 268.08 as in terms of pi. That's not it. And then you rounded correctly for the second piece that said nearest whole number. And then you gave me correctly 268. But that first answer is incorrect. So in terms of pi, I better see pi in the answer. Okay, on the next question right there. Okay, on the next question then, we're revolving about the x-axis. And what do we get on the x-axis? A full sphere or a half a sphere? Half a sphere. Really, our picture doesn't change at all, does it? So when we revolve that about the x-axis, we get the exact same picture. We're getting that half circle, which represents a half of a sphere. So we call that a hemisphere. Okay, off of that. And hold on, guys. Sorry about that. So we got to modify our formula. Okay, we're going to take our sphere formula. But what are we going to do for our formula? How are we going to modify that? Take it by half. So let's make sure we can correctly modify that formula, please, by taking it by half. Radius is not changing, is it? And we did all that work just a second ago. And we just found that full sphere. I wasn't going to change anything. That 256 pi over 3. I mean, we can plug that into our calculator. We got that full sphere to be 256 pi over 3. That's what we do for a full sphere. I do everything the same, but now I'm going to take that into my calculator. Don't put in pi. Calculator can't handle that pi. We want to take 256 over 3 and do what with it? Take it times what? Take it times a half. Okay? So we have that full sphere as 256 over 3, not using that pi key because the calculator can't handle that pi, and take it times a half, or divide it by 2, which is the same thing. Hit enter, and as you hit enter, that's going to give us a what? Half a sphere. One more time, calculator can't handle that. Hit math, and what is our half sphere? Which makes sense. 256, half of 256 is 128. And then we keep that as 128 pi over 3. Okay? And then change it over to my whole number. 268, whatever, but 128, what is it? 128 pi, we just said. 128 pi over 3. Answer is 134. 134 units cubed. And we call that right there. Okay? So nothing crazy going on with that. We've already kind of talked spheres, but there it is. All right, let's go to the next one here. Which, this next one, I like it again because it gets you into using your calculator again with Algebra 2 coming up. Take it backwards. On the quiz, nope, test coming up. You're going to need to work it backwards, I know, on one of these. It's not going to be necessarily a sphere, it could be any of these, but taking that volume backwards, making sure you use the right formula. Obviously it says a sphere, so choose the right formula for a sphere. And what do we know about the formula? Well, it's 4/3 pi r cubed. If it's a cone, if it's a pyramid, if it's a cylinder, whatever formula you've got to use it. All right, we got the volume as 288 pi. And we got to know what the diameter is. First thing you got to know, well, what's the radius? So now we're done with geometry. This is all about your algebra skills. All right, solve an equation. Going back to August. This is one. Go back, and if you get any buddies coming up from, say, 8th grade or coming from Algebra 1 to Geometry Honors next year, you better tell them you better know how to solve some equations, because it is imperative that they do. All right, let's get going here. We gotta get rid of that 4/3 first. We're dividing by 3. We always get rid of division. Inverse of division is multiplication. So we're gonna multiply both sides by 3. Those 3's cancel, and hopefully you realize those pi's are gonna cancel out. Those pi's will cancel out, And 288 times 3 gives me 864. Yep. Again, those pi's are going to cancel out on both sides by dividing. And now that 4 can't do anything yet until that 4 is gone. So we're going to divide. And as we divide by 4, what is 864 divided by 4? Bless you. 864 divided by 4 is what? Divide by 4, we get 216. Now this is a cubed. We know what squares are. We've done those a lot. That's all we've done this year. Cubes are not as obvious for you. So what number times itself 3 times gives you 216? Not obvious, so we use our math button. Option 4 is where that's at. And what is the perfect cubed of 216? Is there one out there? There is. Yep, it is 6. So we're taking the cubed root. Now, how do I know it's a cubed root? That right now is a square root. You got to show what we say is the index. The index is that right there, that 3. The most common index is the square root. Technically, there is a index of what we say 2 there. But when you want to change that from a square root to a cubed root, you change the index to a 3, signifying, hey, you're taking the cubed root. Because, well, it's a third power. And the radius was 6. So what's my final answer? Radius is 6. Diameter is 12 inches. Okay? Make sure you read carefully on the test. Does it want the radius? Yes. Or does it want the diameter? Answer that next piece to it. Okay? All right. Working it backwards. I know you're going to have something like that on the test tomorrow. Not tomorrow, but Friday. And let's do one last one here. Let's do number 3, our composite figure. What do we have in our composite figure here? And what type of a sphere? I'm sorry? Hemisphere? How many hemispheres? 2 hemispheres that make a full sphere, right? So as we look at this one, yeah, we got ourselves obviously a cylinder here. But as we see hemisphere and hemisphere, 2 hemispheres make a full sphere, right? So as this one, we're going to obviously do a cylinder right there in the middle. And we're going to add that to, do I really need to add this as 2 separate hemispheres? No. All we did was take a full sphere, cut it in half, split it apart, add it in a cylinder. You can definitely do 2 hemispheres, add it together, but what we can just make our life ever so slightly easier is just work this as 1 sphere, can't we? All right, oops. What did I forget on my cylinder equation? Pi r squared times the height. So you guys got your formula sheet there. I just didn't write it down right. Okay, let's go at it. For that cylinder, okay, what's the radius of my cylinder there? Radius is 3. That 6 is representing the diameter. So yes, the radius is 3. Radius is 3. Okay, looking at that cylinder. What is my cylinder's height? Hopefully you're agreeing it's not 21. Okay, but what is the height of that cylinder? Radius is 3 here, so radius is 3 here, radius is 3 here. 3 and 3, take those away, is 6. 21 minus 6 is, as I heard from Lucy there, 15. Okay, so we had to go back a little bit. Kind of goes back to some of those tennis ball problems we did with the cylinder. Kind of the same idea. We're good that. And then for the sphere, what's the radius of my sphere? 3. And after that, it's all about our calculator. So let's go to our calculator and let's punch some of that in. It says in terms of pi. So in terms of pi, well, it is 9 times 15. 9 times 15 is what? 135. Again, I'm not using pi. And for my sphere, 3 to the third. 3 to the third times now 4/3. You should be doing that. That one comes out nice because we're dividing by a 3. 27 divided by 3 gives me a 36 pi. Now, again, the directions say write them both. And as you've probably looked at my answer keys, I try to do both of those as I can on those. So in terms of pi, these are like terms. I can add those together. They both have pi. So what is 135 plus 36? 171 pi. Do I have units on that? Is there units there? Centimeters. So centimeters cubed, that's my terms of pi. Better see pi in the answer. And it does say round to nearest hundredth. Hundredth is how many decimals? 2 and what is it? 521 it was? 21. There you go. And we'll call it a year. All right. So that does it. Years is done. Year's done. Now, I lied to you. So what I noticed was yesterday as I was passing out your guys' notes or last assignment, your backside did not have the circles that we had done on sectors and arc length. It didn't print off. So there is one last page I got to give you. It just didn't have it on there. So I apologize. The answer key, review online, and updated. It just did not print off. So my apologies. Appreciate it. Oh, this is part of the test review that I gave you guys yesterday. It's just that it did not print off for whatever reason. My apologies. This goes with your test review I gave you yesterday. Backside was blank, I believe.